Scientific Bioabsorbable Heart Stent Group, and Boston Scientific came to us to design a test for out-of-body conditions to mimic those of in-body. So previous studies have shown they would place iron stents inside rats, and corrosion would, after a year, very little corrosion would take place. When it was out of the body, corrosion would happen within 7 days. So they wanted us to have a more accurate representation between the two. So we hypothesized that this layer right here that's forming of encapsulation tissue is blocking the corrosion rate. So we performed some tests to try and see if we would replicate this. We decided to try and use collagen and coat our specimens in the laboratory to see if we could reduce the corrosion rate. We effectively reduced the corrosion rate by between 200 and 300%. And also notably, we were able to identify the corrosion product, that being of iron oxide hydroxide, typically found at the pH values that found of blood. Another interesting piece of information is the collagen effectively trapped bubble evolution, and we believe this is hydrogen. Typically when it's not encapsulated, there's going to be some kind of formation of hydrogen just from the corrosion process, but this gas gets absorbed into the fluid, where by having this collagen layer, it traps the corrosion, or the gas right there. So Boston Scientific wants to use this for other tests to see if they can trap the gas that way. For future things, we'd also like to characterize the corrosion products forming in the body. We produce some tests where we place iron tubes inside rats, and in hopes that we'd be able to characterize the products. However, after extensive amounts of testing, we were not able to characterize the material because there just was not enough corrosion product forming. So if we left the tubes in there for longer, or had a larger device would have more surface area, we could potentially have more corrosion product forming and be able to identify this.